Hi, my name is Alexander Crupi, and today I will be teaching you about average rate of change and instantaneous rate of change. Alright, so today we're going to start off by copying these two definitions down. So average rate of change is the value of y, the dependent variable, which doesn't change no matter what, divided by the x value, the independent variable, which changes all the time, between specific intervals of a function. So basically what we are trying to do here is find slope. If you recall from grade 9, the slope formula is y2 minus y1 over x2 minus x1. So for example, if we're trying to find the average rate of change between the interval 1 and 3, we take f of 3 minus f of 1 over 3 minus 1, which will give us the slope, rise over run. The second one is called instantaneous rate of change, which is the value of y at an exact x value. This time it is at a specific point instead of an interval. So we're trying to find the slope at a specific point instead of an interval. For example, you'd have to find the instantaneous rate of change for 2. That means you only use that point 2. So you take 2 plus 0.001 and 2 minus 0.001, and then you take 2.001, f of 2.001 minus f of 1.999, and then over 2.001 minus 1.999, and that will give you the instantaneous rate of change. I know it seems a little confusing right now, but it all makes sense once I explain it more in depth and use examples. A construction worker drops a bolt while working on a high-rise building 320 meters above the ground. After t seconds, the bolt's height above the ground is in s in meters, where s of t is equal to 320 minus 5t squared over the interval of t must be greater than 0 but less than 8. Now the important parts of this question are t in seconds, s in meters, the function's equation, and the domain of t must be greater than 0 and t must be less than 8. Now for part A of this question, it says find the average velocity for the interval t must be between 3 and 8. Now the key parts of this question are average velocity and the interval from 3 to 8. The interval from 3 to 8 lets us know that we have to find the average rate of change. Because it's not at a single point. It also means that we have to find slope. Now for part A of the question, it always helps to have a visual around here, so because some of you could be visual learners. So for part A, average rate of change uses a secant line, which basically means it's an interval. So you have to draw a point at 3 to 8, and then you are trying to find the velocity from in between these 2 points only. So this part here basically is what we're basically trying to find, the speed of the bolt at that moment. Alright guys, now for part 8A of the question, we have to, if you recall, we are going to be trying to find the average rate of change, also known as slope between two intervals. Alright, so we should start by writing out the equation, just so we can relate back to it and so we can be efficient. So we already have our x values because the interval represents the x values. So the x values are actually the domain. These are x's. But our y's, we don't know yet. So since this s variable is basically replaced by the y, it's safe to assume that this s is the y. So basically what we have to do is replace this 3 and put it into this right here. Replace the 3 with the t to find the y value. So basically what we have to do, it's going to look like this. So s of 3 is equal to 320 minus 5 times 3 squared. So if you recall back from grade 8 even, that far ago, it's just basically basic bed mass from here. So it's 320 minus 5 times 9. Because of the 3 squared, it's brackets, there's no brackets, and then there's exponents. So we do exponents first, and then the 320 minus 45 because of the multiplication, and now this gives us an answer of 275. Sorry, 275. Now this is one value, but in the slope formula we need 2 values. So what we did to the 3, we're basically going to do the same thing for the 8. So s of 8 is equal to 320 minus 5 times 8 squared. 320 minus 5 times 64 equals 320 minus 320, which is equal to 0. Now that's our second y value. And now to find the slope, we have to use if you recall from grade 9, the slope formula is y2 minus y1 over x2 minus x1. Now these are all just coordinates of points. The points are 3 and 275 and 8 and 0. Those are the 2 points, and we'll make it easier for you, so we're going to label them. So this is y2, y1, x2, x1. So you just fill it into the formula. So m is equal to 0 minus 275 over 8 minus 3, which is equal to negative 275 over 5. Now this is not the correct answer just yet. You always want to reduce it. So it's going to be negative 55 meters per second. Oh yeah, you also always have to do a let statement, or therefore statement, sorry. So therefore, between the interval of 3, t must be greater than 3 but less than 8, the bolt is falling at a velocity of negative 55 meters per second. So there you go, guys. That is part 8A of the question. If you have any questions, just ask me. Now for part B of this question, it says find the bolt's velocity at t equals 2. Our number one first clue is the t equals 2. This means that we have to find the instantaneous rate of change. For part B of this question, we have to find the instantaneous rate of change, which basically means we have to find the average velocity at this exact point right here. This exact point right there. Alright guys, so for part B of the question, it's a little bit different because this time we are trying to find the instantaneous rate of change, also known as AROC. It's still slope, but it's kind of modified in a way that you only use one point, which is t is equal to 2. That's our only point. And so the slope formula is y2 minus y1 over x2 minus x1, right? But since we only have one point, we have to, here we'll label this to make it easier, but it's going to be x2 is going to be 2 plus 0.001 and x1 is 2 minus 0.001. So this is equivalent to 2.001 and 1.999. Alright, so we have our two x values right here. These are like the 8 and the 3, like the interval, but these are the 2 points. So for the IROC equation, it's basically the same thing. So it's IROC at t equals 2 is equal to f of 2.001 minus f of 1.999. Oh yeah, almost forgot. A key component of answering a question like this is always to write the equation down so you're able to go back to it whenever you need to. It'll come in handy a lot. Alright, so which is over x2 minus x1, so 2.001 minus 1.999. So this is our y values up top right here, what we have to find. So it's going to look like this. S of 2.001 is equal to 320 minus 5 times 2.001 squared, which is equal to 320. Remember, it's all bed mass here, so the exponents are first. So it's going to equate to 4.004001. Oh yeah, yes, there is absolutely no rounding here. So you try and keep all the decimal places possible. So keep the decimal places, which is equal to 320 minus 20.02005. Alright, now that is equal to 299.979995. Yes, I know it seems like a big number, but it is going to come in handy if you keep all the decimal places and you don't round. So this is one of our y values up here. This is actually going to be our x2, so the first value. Now the second value is going to be s of 1.999, which is 320. We're doing the exact same thing as above, minus 5 times 1.999 squared. So it's equal to 320 minus 5, which is equal to 3.99601. So as you can see, it's not very hard, but it's very time consuming in a way that you have to write all these numbers down. So our final answer for this point is going to be 300.0199995. Alright, so this is going to be our these are our y points. So this is our y2, so it's going to be first, and there's y1, so it's going to be second. So if you plug it back into the equation, it's going to look like this. IROC at t equals 2 is going to equal to 299.979995 minus 300.019995. So this is our equation, and then it's going to be x2 minus x1, so it's going to be 2.001 minus 1.999. Alright, so for this at the top here is going to equate to negative 0.04, and at the bottom is going to equal 0.02. So if you do the division on your calculator, it's going to come out to negative 20 meters per second. So at t is equal to 2, the bolt is falling at a velocity of negative 20 meters per second. There you go, guys. That is the second part of the question, finding instantaneous rate of change. If you have any questions of what I did or you don't understand anything, just ask me. Well, there you have it, guys. Thanks for watching. I hope you learned more about average rate of change and instantaneous rate of change.